Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. In this chapter, we are going to discuss the sums in the exercise 7.4, page number 316 in the textbook. Okay, my dear children. In the previous class, we have completed 17 questions so far in this exercise. I hope you have learnt well. You understood and you have learnt well the questions, my dear children. Okay, my dear children? Right. Now come to the question number 18. From this question number 18 onwards, from 18, 19, 20, 21, 22 and 23, all these questions are is of the form integral px plus q by square root of ax square plus bx plus c dx, or integral px plus q by ax square plus bx plus c dx. If you observe these integrals, at the time of concepts we have discussed this one, how to find the integral of the functions in this form. What should we do? First, see here in the numerator there is a linear expression in x, and in the denominator there may be a square root, or without square root there may be a quadratic polynomial, quadratic expression in x with the square root or without square root. In this case, okay, my children, we have to follow some procedure, we have to follow some steps. Let us go through the steps. Okay, my children. Okay, right. Come to the question number 18. Integrate 5x minus 2 whole divided by 1 plus 3x plus 3x square. 1 plus 2x, 1 plus 2x, 1 plus 2x plus 3x square. This is a given function. We have to integrate. We have to find the integral of this function. Understood this question, my dear children? If you observe this integrand, it is in the form of px plus q, linear expression in x in the numerator, divided by in the denominator a quadratic expression. In this case, first step we have to take numerator. What is the numerator here? 5x minus 2. We have to assume that 5x minus 2 is equal to a into d by dx of 1 plus 2x plus 3x square plus b. We have to write this equation. We have to consider this equation. They don't give this equation. We have to assume. We have to take this equation 1. Okay, my children. Linear expression is equal to capital letter A into d by dx of denominator, whatever it is, under the square root or without square, whatever the quadratic expression there, we should take the derivative of that function plus capital letter B. From this equation we have to find out the values of capital letter A and capital letter B. Okay, my dear children, please listen carefully, my dear children. You have to follow these steps if the integral is of the form either this or in this form. Okay, my dear children, this is the first step. Understood this step, my dear children? Right. This implies 5x minus 2. I am writing the LHS as it is. Now come to RHS. A into d by dx of, we have to find the derivative of this function. What is the derivative of 1? 0. It is a constant. Okay, my children. Then what is the derivative of this second term? 2 only, because 2 into d by dx of x 1. Here I am writing the derivative of this function directly here. Okay, my children, right. Plus 3 into, what is the derivative of x square? 2x. Understood this part, my children? I found the derivative of this function. I wrote in this square brackets. Understood this part, my children? Right. Plus b. Okay, my children, understood this step? Right. This implies 5x minus 2 is equal to, what will you get here? 6x plus 2 a into 6x plus 2 plus b. Isn't it or not, my children? By simplifying and rearranging the terms in a particular order, we get here 3 2s are 6, 6x plus constant is 2. Understood this part, my children? Right. Plus b. Understood this step, my children? Right. Now we compare the coefficients of x first. We have to compare or equating the coefficients of x on both sides. Equating the coefficients of x on both sides. Then we get from RHS, let us find the coefficient of x. Here, if you simplify 6ax, isn't it or not, my children? 6ax. So 6a is the coefficient of x. In RHS, we get 6ax. X term coefficient is 6a. Isn't it or not, my children? So 6a. Only x term is the only one term. So we wrote 6a is equal to, come to LHS. What is the coefficient of x here? 5. Understood this step, my children? Right. This implies a is equal to 5 by 6. So we got the value of a, 5 by 6. Understood, my children? Right. First, we have to equate the coefficients of x on both sides. Then we got a value. Now, we have to equate the constants on both sides. Equating the constants on both sides. Again come to RHS. First from RHS let us write the constant terms. What is the constant term? 2 into a. What will you get? 2a. There is no x term. Because there is no x term, it is said to be constant term. So 2a. Understood, my dear children? Plus b. This is also constant term because there is no variable. So it is said to be constant term. So 2a plus b. In RHS we get constant term is 2a plus b is equal to, come to LHS. What is the constant term? Minus 2. Understood this step, my children? 2a plus b is equal to minus 2. Understood? Right. So we have already found the value of a, 5 by 6. Now we substitute the value of a in this equation. Okay, my children. Then we find the value of b. So this implies 2 into 5 by 6. 2 into 5 by 6 plus b is equal to minus 2. Because a is equal to 5 by 6 we have already found. Okay, my children. So we substituted a value in this equation to find the value of b. Okay, my children, understood? Right. 2 once, 2, 3 times. This implies 5 by 3 plus b is equal to minus 2. Understood this step, my children? Right. Now we transpose plus 5 by 3 to RHS. Then it becomes minus 5 by 3. Okay, my children. So b is equal to minus 2 minus 5 by 3. Okay, my children, understood this step? Right. This implies b is equal to, take LCM, then what will you get here? Minus 6 minus 5 in the numerator. Understood this numerator part, my children? Right. This implies b is equal to, what will you get? Minus 6 minus 5. Yes, minus 11 by 3. So this is the value of b. Okay, my children? We got the value of a and the value of b. Now let us substitute these two values in equation 1. Substitute a is equal to 5 by 6, b is equal to minus 11 by 3 in equation 1. Then what will you get? 5x minus 2. 5x minus 2 is equal to a. A means what is a value here? 5 by 6 into d by dx of 1 plus 2x plus 3x square. Okay, my children, in the equation 1 we are substituting the values of a and b. Minus 11 by 3. Then we got this value 5x minus 2 is equal to, we can write this one. Okay, my children, understood? So we modified the numerator into this form. Okay, my children, right. Now come to integral. What is the integral? Integral 5x minus 2 by 1 plus 2x plus 3x square dx is equal to. Okay, my children, in the numerator 5x minus 2 is there. Instead of 5x minus 2, we can write this part. Isn't it or not, my children? Right. That is equal to integral 5 by 6 into d by dx of 1 plus 2x plus 3x square minus 11 by 3 whole divided by 1 plus 2x plus 3x square. We wrote the denominator as it is, but in the numerator 5x minus 2 can be written as 5 by 6 into d by dx of 1 plus 2x plus 3x square minus 11 by 3. So I wrote that value here. Understood this step, my children? Right. Next we have to split into two fractions. Okay, my children? Right. So let us split into two integrals. Okay, my children? Right. 5 by 6, that is equal to 5 by 6 integral d by dx of 1 plus 2x plus 3x square whole divided by 1 plus 2x plus 3x square dx. Okay, my children, I wrote this first fraction. 5 by 6 is a numerical coefficient, so I wrote 5 by 6 numerical coefficient before the integral sign. Then I wrote the remaining part, integral d by dx of 1 plus 2x plus 3x square by 1 plus 2x plus 3x square dx. Okay, my children, right. We write second fraction minus 11 by 3 integral 1 by 1 plus 2x plus 3x square dx minus 11 by this number, isn't it, my dear children? Minus 11 by 3 numerical coefficient, so we wrote minus 11 by 3 outside before the integral sign, and the remaining part integral of 1 by 1 plus 2x plus 3x square dx. Understood, my dear children? Right. So let us assume that this is I1 and that integral is I2. So 5 by 6 I1, let us assume that this is I1 minus 11 by 3 I2. That is the equation 2. Let us consider this is equation 2. Okay, my dear children, where I1 is equal to, we write this integral dx d by dx of 1 plus 2x plus 3x square by 1 plus 2x plus 3x square dx, that is I1. Okay, my children. Next I2 is equal to, 1 by 1 plus 2x plus 3x square dx. Okay, my children, understood this I2. So we have to find I1 and I2 separately. Okay, my children, after finding the values of I1 and I2 separately, we substitute in this equation 2 to find the I, capital letter I. Okay, my children, right. So let us find the value of I1 separately. What is I1 here? We assumed here I1 is equal to integral d by dx of 1 plus 2x plus 3x square whole divided by 1 plus 2x plus 3x square dx. Okay, my children. Now there is a formula. Integral f dash of x by f of x is equal to log mod f of x. So log mod 1 plus 2x plus 3x square. If you assume that this is f of x, its derivative is in the numerator, then log mod this function. Okay, my children, because integral f dash of x by f of x dx is equal to log mod f of x. Okay, my children, this is the integral formula. Hereafter, we use this formula also very frequently. Integral f dash of x by f of x dx means in the numerator there should be derivative of the denominator, then its integral is log mod denominator. Understood this step, my children? So we found the integral of this first function I1. Now we find I2. Now I2 is equal to integral 1 by, I am writing that quadratic expression in a particular order, in a standard form, that is 3x square plus 2x plus 1 dx. Okay, my children, I wrote that quadratic expression in the standard form, means x square term, after that x term, after that constant term. Okay, my children, right. Hereafter we follow the methods, we follow the steps as we have followed the steps for the questions 1 to 17. Okay, my children, here in the denominator it is a quadratic expression. First we have to make coefficient of x square as 1. But here what is the coefficient of x square? 3. So we are, let us take it out. 3 is a common factor. So integral 1 by, what will you get here? X square 2 by 3x plus 1 by 3 dx. Isn't it or not, my children? If you take 3 common factor, we get here x square plus 2 by 3x plus 1 by 3. Isn't it or not, my children? Right. If you multiply by 3, if you use the distributive property, then we get the same quadratic expression. Okay, my children? Right. Now here x square we got here. A square plus we have to write this term as 2ab. After that we write b square term. Okay, my children? Do you remember that steps? Right. Integral 1 by a square plus 2 into, we wrote this 2. What is a? X only. X into, what is b here? 1 by 3. 2ab. What is b here? 1 by 3. So plus 1 by 3 whole square minus 1 by 3 whole square plus 1 by 3 dx. I will write here in the numerator dx. Understood this step, my children? In the denominator, this is written as a square plus 2ab plus b square. We are writing to write square of a binomial. We are writing this expression in this way. Okay, my children, this is written as a square plus this second term is written as 2ab. 2 into a means x, b means the remaining part. If you simplify, what you get? 2 by 3x only. So we wrote this term as 2ab term. Then what is b here? 1 by 3. So we are adding b square term and subtracting the same number. Then the expression value does not change. Plus 1 by 3. We write 1 by 3 as it is. Understood this step, my children? Right. That is equal to 1 by 3 integral dx by How can you write these three terms? A square plus 2ab plus b square. Yes, a plus b whole square. So x plus 1 by 3 whole square. These three terms can be written as square of this binomial. Isn't it or not, my children? Right. Then what are the terms left here? Minus 1 by 9. 1 by 3 whole square. What is the value of 1 by 3 whole square? 1 by 9 plus 1 by 3. Okay, my children, because a square plus 2ab plus b square is equal to a plus b whole square. By using this algebraic identity, we wrote these three terms as the square of this binomial. Understood this step, my children? I wrote the remaining two terms as it is like this. Okay, my children, understood this step? Right. Now let us simplify these two numbers. Okay, my children. In the rough work, let us take these two numbers. First, write positive number 1 by 3 minus second number 1 by 9. What is the LCM here? 9 is LCM. 3 3s minus 1, that is equal to 2 by 9. By simplifying these two numbers, what will you get here? 2 by 9. Okay, my children? Right. So 1 by 3 integral dx by x plus 1 by 3 whole square plus 2 by 9. Understood this step, my children? Right. Now it is in the form of integral dx by x square. Consider this entire part as capital X in your mind. Plus this term should be written as square of some number. But here 2 by 9 is there. We should write this number as square of some number. How can you write? Root 2 by 3 whole square. Isn't it or not, my children? So in the next step, we write this number as square of some number. Okay, my children? Right. So that is equal to 1 by 3 integral dx by x plus 1 by 3 whole square plus root 2 by 3 whole square. I wrote this number as square of some number. If you simplify this number, again we get the same number 2 by 9 only. Okay, my children? Understood? Right. Now if you observe this integral, it is in the form of integral dx by x square plus a square. Standard form. What is the form? Integral dx by x square plus a square. What is the formula? Yes, 1 by a tan inverse of x by a. We use that to integral formula. Okay, my children? Understood? Right. Now come to this step, my children. It is in the form of integral dx by x square plus a square. Previously I told you it is in the standard integral formula. What is that formula? I will apply here 1 by 3 into 1 by a. What is a here? Root 2 by 3. Root 2 by 3. 1 by a. Tan inverse of x by a. What is x here? What x plus 1 by 3 by a. Root 2 by 3. Because integral dx by x square plus a square is equal to 1 by a tan inverse of x by a. By using this standard integral formula, I wrote this step. Understood this step, my dear children? Right. Now let us simplify these two numbers. What will you get here? 1 by root 2. Okay, my dear children? Tan inverse of, here what will you get? Denominator gets cancelled. 3x plus 1 by root 2. By taking LCM, then we get in the numerator 3x plus 1 by 3. 3 gets cancelled. Okay, my children, this is I2. Therefore, I2 is equal to 1 by root 2 tan inverse of 3x plus 1 by root 2. But actually, what is I? We have to find the value of I. So therefore I is equal to, what is I? Equation I is equal to 5 by 6 I1 minus 1 by 3 I2 from equation 1. Isn't it or not, my children? Minus 11 by 3. 5 by 6, A value is 5 by 6. So 5 by 6 I1 minus 11 by 3 I2. So substitute 5 by 6. We found what is I1 here? Log mod 1 plus 2x plus 3x square. This is I1 value. Okay, my children. Minus 11 by 3 into what is I2 value? 1 by root 2. 1 by root 2. Tan inverse of 3x plus 1 by root 2. We substituted I1 and I2 value in the equation 1. Understood this step, my children? Right. Now let us simplify this one. 5 by 6 log mod 1 plus 2x plus 3x square minus 11 by 3 root 2 tan inverse of 3x plus 1 by root 2. Integral part is over and the simplification part is also over. Okay, my children, this is the last step. At the last step, what should we do? We have to add constant of integration. So plus c. Understood, my dear children? Right. Try the remaining questions in this exercise, my dear children, by following these same steps. Okay, my dear children. Question number 19, 20, 21, 22 and 23. Same as of this question. Okay, my dear children, follow these steps and find the integral. Okay, my dear children, if you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children, right.